A simple question on binomial probability. Missile hits a target successfully is 0.75. Probability of hitting on target is 3/4. This is taken. Now that means if I call this as P, there can be a probability of failure of not hitting on target, and that can be 1/4 is equal to Q. This being a case of binomial probability, you see, in order to destroy the target completely, at least 3 successful hits are required. At least 3. 3 or more. 3, 4, 5, 6 and so on. Now, if I fire n number of missiles, not all of them are going to hit on target. Then the minimum number of missiles that have to be fired, so that probability of completely destroying the target is not less than 0.95. This is a complicated sentence. Now, minimum number of missiles fired. Let's say we fire n missiles. Out of them, how many would be successful? Let's say R. This is, let's say, probability of R successes out of n attempts. In a binomial probability, counting would be P to the power R, Q to the power n minus R. These are chances of R successes, out of n trials. And therefore, when you go for firing 3 or more missiles successfully, it is equivalent to 1 minus probability of 0 successes, 0 on target, minus probability of 1 hit, minus probability of 2 hit. Now, whatever remains is a probability of 3 or more successful hits on target, and this should not be less than 0.95. Now, you read the question again. The minimum number of missiles that have to be fired, let's say that is some n missiles, so that probability of completely destroying the target is not less than 0.95. So therefore, 1 minus P of 0 missiles on target, or minus 1 missile on target, minus probability of 2 missiles on target is greater than equal to 0.95 is what the question requires for you to solve. Out of n missiles targeted, how many missiles would fire successfully or hit the target successfully should be minimum 3. Now see this, 1 minus 0.95 is 0.05, greater than equal to probability of 0 hits on target, probability of 1 missile on target plus probability of 2 missiles on target, and this is probability of, let's say, R missiles on target. Let's say this is chances of R successes out of n trials, RH, 0H, 1H, 2H. I hope now you can match these probabilities with this calculation. So we say that this is 5 by 100, 1 by 20 effectively, should be greater than equal to P of 0 plus H. 0H. 0H means NC0, which is 1, P power 0, which is 1, Q to the power N. Q to the power N means 1 by 4 whole power N, plus, now 1 missile on target, therefore NC1. Out of n missiles, out of n trials, we are having only 1 success. That means NC1 is N, P power 1, that means 3/4 to the power 1. And remaining failures, how many failures? N minus 1, 1 by 4 to the power of n minus 1, plus 2 missiles on target, that is NC2. So therefore n minus 1 by 2 factorial, n minus 2 factorial cancels into P power 2, that is 3/4 whole to the power 2 into 1/4 to the power n minus 2. This is going to be a basic calculation which we will solve. So while going ahead, 1 by 20 greater than equal to, let's take 1 by 4 whole power n common and out, that is 1 plus 1/4 power n leaves behind only 3n, plus n into n minus 1 by 2, 4 power n out, therefore 3 square, only 9 left. You see this, n into n minus 1 by 2, 4 power n out, and 3 square 9 inside. That's all. Now, when we resolve this inequality, we will come across a problem of solution. We will see how to solve that. So, before we go ahead, let's make some space. Say this, 4 power n, let's say we take it this side, by 20. This should be greater than equal to 1 plus 3n plus 9 by 2 into n square minus n. Yes, that is correct. Now let's multiply by 2 on both sides. So 4 power n by 10 should be greater than equal to 2 plus 6n plus 9n square minus 9n. So therefore 4 power n by 10 should be greater than equal to 9n square minus 3n plus 2. This quadratic can be converted into a perfect square plus constant. This is equivalent to, let's say, 3n whole square minus 2 times half into 3n plus 1 by 4 plus 2 minus 1 by 4. So effectively we are dealing with 4 power n by 10 greater than equal to a perfect square plus a constant. So therefore 4 power n by 10 should be greater than equal to 3n minus half whole square plus 8 minus 1, 7 by 4. This is what we need to see for solution. Now in this case, let's try for values of n. Let's say we put n is equal to 5. Then what are we going to get? N equal to 5 means 4 power 5 by 10 would be equal to like 2 power 10 by 10. Therefore 1032, 2 power 16, 32, 64, 128, 256, 512, 1024 by 10 is equal to 102.4 approximately. 2 power 10, 112, 1024. So this is approximately 102. Now on the right side, compared to that, on the right side at n equal to 5, 15 minus 0.5, that is 14.5 plus 7 by 4. How much is this? Close to. This is in fact lesser than, this is in fact little less than or very close to 15 square. Yes, a whole square, 15 square. That is 15 square will be how much? 15 into 15, 15 times is 75, 15 on the 225, and let's say this is somewhere close to 224 or 220 or like that, but this is definitely not much greater. Like you can say this is lesser, so this does not satisfy, so n equal to 5 fails. Likewise, we can make a trial for n equal to 6. At n equal to 6, we can have 4 power 6 by 10, that is 2 power 12 by 10, and that is equal to let's say 2 power 10 into 4, 4 into 2 power 10, which is equal to 1024 by 10. So that's going to be 4096, and that is close to 409.6. So let's say this is the left side, and on the right side we have at n equal to 6, 18 minus 1 means 17.5 whole square minus or plus 7 by 4. This is approximately close to how much? Let's say 17 square. 17 square is, I think, 289. 7 sevens are 49. Let's say 7 sevens are 49. 4 comes. 7 plus 7, 14. 14 plus 4, 18. 18 and 2, 289. This is close to, let's say, 289. And this is far greater. Now, therefore, n equal to 6 solves this inequality. And hence, the answer to this question is n equal to 6. I hope you have followed the calculation. You have to do a bit of approximation here to solve. And this is how we get an exact integral answer to this question. Thank you for your patience. See you in the next discussion.